All right, so welcome back. Thank you a lot for the opportunity to talk to you today about CVM-FS. I'm Valentin. I'm actually a physicist by training, and before working on CVM-FS, I would actually also worked on building a software stack for a future collider at CERN. So there's basically a lot of simulations involved that's going on there, and I know very well the pain and all the effort that goes into building something like this. So I can very much relate to this here, and it was very nice to see all the progress that is being made in this area. So CVM-FS, also known as the file system layer of EasyBuild. You've already heard, okay, before actually talking about what is CVM-FS, I want to remind you of kind of like a simple effect. So say you pull a Docker container for R, the statistical library, just in case. It's on the order of hundreds of megabytes to a gigabyte. Now, if you run a simple thing in this container, the files that you actually use are about 30 megabytes. And this is actually a statistical fact that for containers, you tend to use around 15% of the actual files in the container. So this is not super efficient. And especially in scientific context with distributed computing resources, now you tend to have jobs that try all to start on all machines at the same time. And in the past, no, also at CERN, we used to use a shared file system. Who knows the Andrew file system, AFS? Ah, there you go. It's actually quite nice. We still use it for home directories. Didn't work too well if you put your software there and then have hundreds of compute nodes try to read the software from the same time. What you actually effectively do is a distributed denials of service attack then on this particular server. And in particular, this is also very heavy on the metadata as you try to kind of like list all the libraries in these paths and evaluate all of this. So one thing. Basically, a very innovative out-of-the-box solution to this is CVM-FS. What is CVM-FS? Is a global read-only file system for software distribution. And the user experience is kind of like similar to an on-demand streaming service, but for scientific software. Today, Lara actually showed a very nice demo of doing this really live, but basically just mount CVM-FS as a file system mount on your machine. And then you will have basically a just-in-time download of all of the files that you access. So this is then has a bunch of very nice features. It's backed by a content store that's content, an object store that's content addressable, and this allows you to duplicate files that are used by different packages. It makes use of a very simple HTTP transport that allows us to do very effective caching. We then can do compression. We can do cryptographics to verify data integrity and a lot more. And just behind the scenes, this is a file system in user space, which is a very nice technology that basically allows you to implement syscalls to do whatever you want them to do. And basically, as an application, what you do is you do an ls on CVM-FS, for example, and this will look really much just the same. So it's running syscalls, and then the fuse kernel module will actually redirect the syscall to CVM-FS and ask it what to do. And what we want it to do is basically very simple. If the file that you want is in the local cache, we use that. If the file is not in the local cache, we download this from our object store and place it in the local cache and then use that. And then there is a lot of stuff that goes on to make sure that the metadata and all of the optimizations for this are there. I mean, you can see that there is always going to be some overhead of this redirection. That's a feature of fuse file systems, but it's a very effective way of dealing with this. So originally, this was developed for the Large Hadron Collider at CERN. When we have something that we call computing grid, there is this idea that we connect kind of like all of the computing resources around the globe of universities participating in the Large Hadron Collider. And it's similar to the electrical grid where you can just plug in something and you get electricity from who knows where. Here you can just plug your job into this computing grid, and it will kind of like run, and you don't even need to concern yourself too much. And what it did very effectively is provide this uniform computing access to all resources that were pledged to the LHC. This kind of like sounds familiar from this morning. I think the idea of these kinds of federation is very much the same, and I can encourage you to also look towards this WLCG, this what LHC computing grid, if not maybe for specific technologies, but also kind of like from the experience of building such a collaboration. And as an aside, nowadays actually the LHC is using more and more HPCs, so resources is not really actually that we want to, and we think that this is more ideal. In high energy physics, we tend to do high throughput computing much more than high performance computing. But more and more countries just kind of like pledge HPC resources towards the LHC. And we have to kind of like figure out a way to make use of that. Part of this is for us, is very, CVM-FS is very essential. All right, so the basically all of this was shown this morning as well. So in backing CVM-FS is this kind of like tiered architecture of a central repository server, the source of truth, and then different copies distributed on stratum 1s, and then proxies, and then kind of like this really avoids this particular problem in distributed. Right, so CVM-FS at CERN in numbers. So we have around 15 stratum 1s for our biggest repositories, counting around 4 billion files in /CVM-FS. There's around 2 petabytes of data. And I'm going to talk a bit more about this 100 petabyte figure that is here later. I'm also going to talk more about container images. Maybe to point out, it's interesting that we've also seen that the software tends to get much more complex. So this is my takeaway from this particular graph up here. So we've seen that the TensorFlow and all of these machine learning libraries that are actually kind of really involved and complicated to set up, and they're actually also really kind of change a lot. So it's used very heavily. It's used at a large scale. But it also works very well at this scale. And maybe also worth pointing out that we're also very happy to have this large tail of smaller repositories. Sort of there's really a big number of users, not even just at CERN. Sort of there's also in astronomy, astrophysics, and other disciplines. Right. So the code and components, I figured since we actually the development team, I quickly show this as well. We have basically the core, which we call the client and the server. Sort of the client is what you would run on your worker nodes, and the server is what allows you actually is to get the software into /CVM. Then we have some container tools, also to be talked about later. And there is a gateway that allows you basically to use multiple publishers publishing to the same repository. This gateway has an interesting history. Nowadays, these tools are all written in Go. It was actually started in Erlang and was an interesting experiment to use. For us, interesting as well are these standalone utilities, the preloader and the shrink wrap, that are in particular relevant for HPC. Then we have a couple of nice extras. So there's a GitHub action that allows you to use CVM-FS on GitHub action runners. There's additional monitoring, and there's different things here. And this tends to be in a CVM-FS contrib repository that's then also maintained oftentimes by the community, which is great. Right. So currently we are at CVM-FS 2.12.7. Just to say, maybe to point out here as well that there is a note that we have found a problem in testing, and actually that CVM-FS goes through quite involved tests at CERN. Sort of CERN IT has a quality assurance fraction of their batch system, which is dedicated to testing new CVM-FS. Maybe also an interesting feature of CVM-FS is that usually with a file system like this, you'd have to unmount and restart the file system when you upgrade, in particular for fuse file systems. We actually have a hot patching feature that allows you to to upgrade without actually interrupting any running processes. I mean, it does do a reload and quickly pauses the process, but that is something. Quite a bit of work goes into it to ensure that actually you can very smoothly and easily upgrade. So for packaging, we also provide packages. I flash here the kind of like the list of platforms that we support. I think Fedora 41 and 42 is already also already have. There is SUSE here as well, since I think that's also quite used quite a bit. In principle, all of this is here. Sort of, you've also seen that at the moment we have our own package repository for these things. I think be happy to get these also into upstream repositories for Debian and Fedora, and happy for any help that anyone support us here. And also do consider using the CVM-FS testing repositories. This is also kind of like very stable usually, but it basically gets you the newest version a week early, and if you install this on a fraction of worker nodes, lets you update also in very good, very calmly, and you're sure that there aren't any problems. So talking about HPC, we know that there may be a lot of restrictions, and I'm going to talk a bit about the workarounds that exist at the moment, and the pros and cons of all of these. So the best case is for CVM-FS is always the one that's shown here. So you have a core, it has access to the internet, and it has a CVM-FS basically mounted directly on the node, which can talk to the Stratum 0. And kind of like the worst case is here, where you have no internet, kind of like no possibility of talking to the Stratum 0. And there are quite a few workarounds that go into then doing this. I'm going to talk about these now. So the first one is for when you have no admin privileges. Like you're out of luck, your sysadmin doesn't trust you in that sense. So to mount CVM-FS as an unprivileged user, there is a collection of bash scripts called CVM-FS exec, maintained by Dave Dykstra, who's also very much involved with the Obtainer project, so that there's someone who really knows kind of like all of the edge cases of running like this. Basically what CVM-FS exec will do is download the CVM-FS packages in a directory that can be accessed by the user, and then mount CVM-FS somewhere that can be accessed by the user, and then try to make sure that the process that you want to run actually has seized on the mount point at /CVM-FS. There are several modes, so that this can get a bit involved. It depends a bit on the availability of certain features on the host. So the easiest one is this with if the OS actually supports unprivileged namespace fuse mounts. That is usually the case after the downside that you have with this approach is that usually you don't really get to share. It works very well, but you don't really get to share the cache between on the system. That is usually where CVM-FS offers a lot of benefits. Next one, for when you have no internet connection. So basically, there is a tool called CVM-FS shrink-wrap that allows you to do this workflow that is shown here. Basically, is to copy out all of the data from CVM-FS. Now, basically said, CVM-FS is a POSIX file system. No? So in principle, you could also just copy files to an rsync. This is a bit more efficient as it keeps this deduplication that we have. So it won't actually copy things twice, and it allows us also to be a bit to remove some of this overhead of the fuse module. So that this is then the recommended way to do this. And some experiments have actually like a very sophisticated framework where they run a test job actually, and then they trace just the files that this test job is accessing, and then they shrink wrap only this, and then they will basically ship that to the node. A similar tool is CVM-FS preload that basically does the same thing, but it fills the cache of CVM-FS, so you can still like access /CVM-FS and all of the files. But you actually have to run CVM-FS then. CVM-FS shrink wrap just gives you basically a folder with the content of /CVM-FS. The downside here, this is a lot of work. So that is. And finally, there are cache configurations for when you have no local disks. I've also learned at this workshop why that's an HPC sometimes actually really a requirement, and why these machines are set up like this. So here the first option is to use a loopback file system for the cache. This removes, for when you have cluster file system, this removes much of the load on the metadata server, because the cache is really a lot of small files, so this can be an option. And we have a feature that actually lets you put the RAM in the cache in RAM or in a RAM disk, and also have a tiered cache that kind of like the RAM as much as possible, and then goes here. So I think these are options that can be explored. Yeah. Right, alien cache is another possibility to use this. That basically says also that the cache can be found at an external location. What we no longer recommend is actually doing NFS exports. This is something that is also specific to Cray, where manufacturer recommends to run files on a particular admin node. I mean, this can be made to work. It's running at some Cray sites at the moment, but it can be inefficient, and it can be a headache. And then we had something which is called a parrot connector that is also not really supported for at the moment. Right, talking about the infrastructure backing CVM-FS. So here we said that there are proxies and the Stratum 1s. We recommend to actually put to set up a Stratum 1 if possible. It takes like a bit of disk space and a dedicated machine, but also gives you ownership of kind of like all of the software in a repository. A Stratum 1 can actually be converted into a Stratum 0 and back, and kind of like can give you a possibility to back up the repository, as well as then kind of like really have it locally here. For proxies, Squid is kind of like the default recommendation, as this was the production workhorse in HEP. And there are historical reasons around this. So CVM-FS actually could make use of proxies that were set up for a distributed database called Frontier that was used in high energy physics. And so nowadays, most of the configuration in high energy physics is targeted at Squid. It has the advantages of forward proxy by design, but it has been, there are concerns around the maintainability, let's say, of this sort of. There are several bugs that are known in Squid that kind of like have to be worked around and haven't been able to be upstreamed. Also try to investigate alternative here. One's Varnish cache, and here you can find the link to a working VCL. So if you're interested in trying out other proxies, then please do talk to me. I think I also know of people that have used Nginx for this particular purpose. So one new use case with EasyBuild is the partial Stratum 1s. So I've heard that sites, might want to actually only replicate the part of the repository that is relevant for their computing architecture. So this we're very open to supporting. It will need some thinking because of this feature that usually Stratum 1s can be converted back to Stratum 0s, and here we'll have to figure out how to actually then give a clear model of then how you can do this. All right. Because this was mentioned this morning, also a word around licensed software and private repositories. The legal situation around distributing binaries of licensed software on CVM-FS is not exactly clear. Sort of, there's a 2-year discussion going on at CERN with both Intel and NVIDIA if this is actually is covered by the license agreement or not, since it's actually the public distribution of the binaries. Doesn't seem like it actually really is possible to even if there is a separate license server. There was a feature in the past to have authenticated repositories. This is also not really recommended and will be deprecated at one point in the future. The approach that we took at CERN is to have a dedicated repository that is only available on the internal network. Sort of this, one of the solutions that. All right, I'm going to touch briefly upon a few further topics that are not directly related to HPC, but shows a bit what else is going on in CVM-FS. So basically, we always try to work a bit on performance improvements, and here are a few technical topics. A lot of this is the performance in CVM-FS hinges on caching. So we've done some work to make better use of the page cache tracker in the kernel, and also this symlink cache that's available on newer kernels. And you can see that with all of this now throughout the CVM-FS versions, you can get the access times quite a bit down. So this is very nice results. Even after that's. It's a mature project and has been developed for more than 10 years. There's still some gains. If you've actually, most of the problems that we've seen recently with CVM-FS actually were connected to very wide machines with many cores. And here there is now a default option of using a ref-counted cache manager, and that also improves the situation a lot. So, and we actually have also users from industry. So in particular, I want to mention Jump Trading, which actually also sponsors some developments in CVM-FS. This is very nice, and we want to thank them. You can actually see Matt and Harvey's presentation for more details here. So that this is an engineer from Jump Trading, and it's a very interesting use case. So that they have a large archive of market data. And they wanted, for historical reasons, they always had this on a POSIX file system, and when they moved this kind of like in a cloud S3 bucket setting, they had to keep compatibility. And what CVM-FS offers them is kind of like a read-only POSIX file system view on this market archive that is by now, like, I think, more than 100 petabytes of data. So that this. In general, once people start to wrap their head around CVM-FS, this is a question that often comes up. If you can put arbitrary data on CVM-FS as well, is of course optimized for the software distribution use case. And software we actually mean kind of like the access pattern and the possibility of caching and the deduplication that you have. So to first order, it's really the software distribution use case is the one that best used for. You may or may not be too much interested in macOS. We still have kind of like a lot of physicists who ask us to make CVM-FS work on their MacBooks. It's a bit of a tricky situation as kernel extensions, and to make Fuse applications work on macOS is kind of like a headache. And it's lucky you if you don't actually need to think about this whole problem. And then this slide. Actually, this answers perhaps the most interesting question is why is it called CernVM-FS? So actually the reason is that there used to be an actual virtual machine image that was called CernVM. That was very, very minimized. So it was what they called a micro image. And what CVM-FS was used for is actually just to distribute the whole root file system for this. Only the bootloader was in the virtual machine image that reduced it to around 20 megabytes, which I think is incredible. And then the whole operating system was actually loaded from CVM-FS. Kind of a side effect of CVM-FS is always that you get software preservation basically for free. Because of this object store and the way that people usually use CVM-FS is really efficient to actually just keep around old software. And people have really come to appreciate this. So that it's used a lot for different use cases at CERN, for example, software preservation. Aleph was an experiment at LAP. This was an collider at CERN in the 1990s. And you can see that nowadays you can still use software and data from 15. Nowadays it's 20 years ago via CVM-FS and CernVM. Right. So containers. I think that actually EasyBuild has found a very nice approach to delivering software in these containers without the containing that was mentioned this morning. Is still actually possible to combine CVM-FS and containers. What you can do is basically to unpack the complete root file system on CVM-FS, and in the easiest use case, Aptainer basically allows you to run a container just from here, and then you get basically this lazy loading that I mentioned in the beginning. So you really only download whatever you then for your workload, and you get this cache management that also lets you be more efficient here. Another way to use this is nowadays through containerd. So containerd allows you to write snapshotters, and there are a couple of snapshotters that have been written that allow you to do lazy loading. And you can see that apart from our snapshotter that uses CVM-FS basically to load the layers, there is StarGC and Sochi, the basically newer snapshotters. And basically all of these allow you to really drastically reduce the startup time for containers and then the data that you actually need to. This is I think a very attractive idea and can be used with different tools, also Kubernetes, and since very recently also Docker. And this is I think very nicely because it's completely transparent. Once you've set up the containerd and the CVM-FS snapshotter, all of the layers that you can find on CVM-FS are basically lazy loaded, and the rest is fetched from the registry. So it never tells the user, okay, this doesn't work. It's always working, and it will speed things up if possible. So in conclusion, CVM-FS lets you stream software on demand. It's a mature project that really has long-term support, and I think I'm serious about this. So it's a mission-critical piece of software for the CERN experiments, and this is then still going on until at least 2040. Part of the trade-off here is also that the new features are sometimes a bit slow to get into CVM-FS. We try to be very quick with bug fixes, but then the upside is that is kind of like a very stable project. It has a lot of users, so if I'm happy to have Easy as a user, but there's also Euclid, LIGO, and other astrophysical users. Software preservation tends often to be a concern for academic user, and this is basically built into CVM-FS and has much appreciated at CERN. To get started with CVM-FS, there was this tutorial that was organized by a few great people here, and that I link here as well. And I also leave some links to the website, the docs, and you can also get in touch with me directly. I should be on the Easy Slack as well, but not always dimensions directly. So get in touch. We're also happy to work with you if you have a particular constraint and work with a particular technical situation on your side. All right, thank you very much.
Questions? Hi, Valentin. So what happens if you start a file with CVM-FS? And if I start it again? I ask because we also install, for example, Abacus on CVM-FS. And the latest version of Abacus is doing, I think, about 1 million stats on some files. And it takes hours. So for us at the moment, the new Abacus versions are not usable via CVM-FS.
Right.
Any solutions?
I mean, I think we'd have to talk a bit in detail about the particular access pattern here. So for start, I think the CVM-FS has a particular system of handling metadata of the files, basically the file names and all of these things. And as I said, there is also a very recently StatFS cache that is used in the kernel. That only helps you for repeated accesses. If you try to read something from like a lot of files, one thing that can help is to actually work a bit with the details of how this metadata is created and stored. This we call catalogs, and there is a bunch of documentation also how to best create catalogs in order to make this work. But let's chat about the
Okay, thank you.
If it works, maybe you can take this one.
Hi, you mentioned that X509 certificates are going to be deprecated in the future. Are there any plans to get encryption in flight for CVM-FS data?
I'd really like to avoid it, actually. I think it's a feature that is quite, yeah, it's hard to maintain, and it's just if possible, I think it makes our life much easier, and it makes it more effective if we keep it to basically public world readable.
I maybe have a question just about, I'll come over that way, about monitoring. So we don't do it at the moment. I know that you do. You monitor the usage, or at least to know who's hammering your S1 servers and things like that. Is there any maybe advice for us in that space? So that, like, how do we analyze the behavior? We don't see problems. Probably we wouldn't see problems unless we started looking as well.
Yeah, so for workarounds, I think one of the best advices is to monitor the cache cleanups. The CVM-FS is basically has a model of the cache where you then clean up files, and the number of cleanups here actually gives you a very good idea of if you effectively set up your cache. Kratom ones, I'm not directly involved. Sort of there is quite some expertise around this and this computing grid that I've mentioned, and I think we're also trying to share more a bit this.
Just a correction to one of your slides, Cray does not use NFS.
All right.
It uses DVS, which is its own system and which is completely different. I mean, you run into the same issues with CVM-FS, which is why the environment variable that you need to set to get it working has NFS in the name. But if on a Cray system, if you would use NFS, you would run the NFS client also on an admin node and use DVS to get it to the compute nodes.
Right.
So NFS would be at the same level as CernVM-FS would be on a Cray system. But it's a bit confusing in the documentation because the Cray documentation is like in between two sections about NFS.
All right, I see. Okay.
Yep. Maybe last one. I think we're trying to keep the schedule.
I realized that when you're updating software in such environments, you can end up with libraries that have malicious code. Yeah, like Python libraries from PyPy that end up slightly different because PyPy there's no control over that, or NPM or yeah, JavaScript, stuff like that. Is there a way to plug in something akin to an antivirus or something like that, like that makes an action on the receive of every file to this thing?
Right. So what we do on the technical level is kind of like to ensure that what you get on the client is the same thing that you published on the server. Sort of is whatever the admin of a repository publishes. You have to trust your admin. Basically, this is the thing, and that is part of the setup. I think. I don't know if you could set up a system where you'd allow anyone to publish, and then you still get kind of like a trusted thing. But I mean, there is cryptography and there are certificates involved that kind of like ensure that that you know the content of what the client sees is actually the same as was.
There's one more question here, but let's do that while the next speaker gets set up.
In CVM-FS, if you have larger files and certain blocks are requested, do you just send the block or the whole file?
Right, so we actually chunk files internally. Sort of the large files are broken up into chunks, and then there's actually also the possibility, if you only do a ranged read, only kind of like the chunks that you really read are going to be transferred.
Thanks a lot, Valentin. Now we have Pavel